Hey guys, welcome back. I hope you all had a very relaxing spring break, and today we're going to jump right in and start chapter 13. So, chapter 13 is about periodic functions and trigonometry. Section 1, which we're going to be talking about today, is exploring periodic data. Our objectives that we're going to meet for section 1 are to identify cycles and periods of periodic functions and define the amplitude of periodic functions. So before we start, let's look at this example. What do the situations shown have in common? Explain. So our first picture is the Earth rotating around the sun. Second picture is a heart. Third picture is a girl on a swing. And the fourth picture is the ocean. So what do all of these situations have in common? Well, all of these situations have a repeated pattern. That occur at regular intervals. A heart contracts and expands when it's pumping blood. The earth orbits the sun, a swing moves forward and back, and the ocean moves up and down as the waves pass. These situations can tie into a periodic function. A periodic function is a function that repeats a pattern of y values or outputs at regular intervals. So, a periodic function, you're going to see your y value repeat. One complete pattern is a cycle. A cycle may begin at any point on the graph of a function. The period of a function is the horizontal length or the distance along the x-axis of one cycle. So your period is just the length of one complete cycle. And the x value in a periodic function often represents time. Essential understanding for this section: periodic behavior is behavior that repeats over intervals of constant length. So let's start by identifying cycles and periods. First example: analyze the periodic function below, identify the cycle in two different ways, and what is the period of the function. The easiest way to identify a cycle of a periodic function is always to look at the maximum values. At other points in the graph, it might get a little bit confusing, but the maximum values are very straightforward. So we know a periodic function, our y value repeats. So our maximum is at our y value of 2. Once we hit this y value of 2 again, that represents one complete cycle. So one cycle of this function is between our maximum values. So from that, we can determine the period, which is just the length of this cycle. The cycle starts, our first maximum is at the x value of 2 and ends at the x value of 6. So this period, the length, is 4 units. Using that period, we can figure out another cycle. So another cycle, we can start anywhere on the graph. So say we start here. That is at the x value of 8. In order for this cycle to match up with our period, which is 4 units, it would have to end at 12. And we know that's correct because that gives us a period of 4 units, and our cycles end at the same exact y values. So the period of this function, or the length of a cycle, is 4. And we've shown two different examples of this cycle, one between our maximum values and another one that starts and ends at the same y value with the period of 4. Let's look at another example. Analyze the periodic function below. Identify the cycle in two different ways. What is the period of the function? So again, it's easiest if we start by looking at our maximum values. So our cycle is going to begin and end at the same y value. So here's one cycle of this function. And we can determine the period by finding the distance or the length of this cycle. So our cycle begins at the x value of -3 and ends at the x value of 1, which gives a period of 4. Using this period, we can figure out another cycle in this graph, starting at any x value on the graph, it doesn't matter. So say we start at the origin, or an x value of 0. to complete this cycle, we would have to end at 4. So here is another cycle of this graph. Begins and ends at the same y value, and our period, or the length of the cycle, is still 4. So we have a period for this one as well of 4. You can also analyze the graph of a function, determine if the function is periodic. So let's identify periodic functions. So here we have 2 examples. Is the function periodic? If it is, what is the period? So remember, for a function to be periodic, it has to have a repeating y value. So say on our graph of A, we start at one y value of 3. For this function to be periodic, our graph would have to hit 3 again and again and again in a pattern, but you can tell that is not happening. Our graph is decreasing as it goes, so this function is not periodic. For B, we can look at our y value of 4 here. We have a maximum on this graph here. We have another maximum at 10. So this is periodic. And the period from 0 to 10 is 1 cycle. So our period is 10. That's 1 cycle of this function. And the pattern will continue on. The amplitude of a periodic function measures the amount of variation in the function values. The midline is the horizontal line midway between the maximum and minimum values of a periodic function, and the amplitude is half the distance between the maximum and minimum values of the function. And to figure out our amplitude, we can use this equation at the bottom. The amplitude is always equal to 1/2 the maximum value minus the minimum value. So looking at this example, here the maximum value of our graph is at y equals 3. That's the maximum value of our graph, and the minimum value is at -1. The midline of our graph is always going to be exactly in between our maximum and our minimum. So the midline, the equation of the midline in this case is y equals 1. That's 2 units away from the maximum and 2 units away from the minimum. We can find our amplitude by taking the maximum value minus the minimum value and dividing by 2. So our maximum value is 3 minus -1 gives us +1 over 2. 3 plus 1 is 4 over 2, so our amplitude of this function is 2. And you'll notice your amplitude always matches up with the distance between the maximum and the minimum, and the line that the equation that represents your midline. So 3 is 2 units away from our midline, which is 1. -1 is 2 units away from the midline, which is 1. Finding the amplitude and midline of a periodic function. So let's look at a few examples. First one, what is the amplitude of the periodic function? What is the equation of the midline? So in order to find our amplitude, we need to know the maximum and the minimum of our graph. Our maximum, which is represented by this dotted line here, is at 4. The minimum is at -2. So to find our amplitude, remember we do maximum minus minimum divided by 2. So that's going to be 4 minus -2, which we can write as +2 over 2. 4 plus 2 gives us 6 over 2, so our amplitude is going to be 3. The equation of our midline, remember the midline is directly in between the maximum and minimum. So directly in between 4 and -2 is going to be 3 units away from each of these. So our midline is going to be at y equals 1. And we can draw that into our graph here. a dotted line for our midline at y equals 1. Our next example, what is the amplitude of each periodic function and what is the equation of the midline? So again, we need to start by finding our maximum and the minimum. The maximum of our first function is at positive 1 and the minimum is at negative 2. So to find the amplitude, we're going to do 1 minus negative 2, or 1 plus 2 over 2. 1 plus 2 is 3 over 2, which we can write as a decimal as 1.5. So the amplitude of this function is 1.5. The equation of our midline, remember the midline is exactly in between the maximum and the minimum, and we can use our amplitude to help us figure out that distance. So our amplitude is going to be, or our midline is going to be 1.5 units away from both the maximum and the minimum, which is going to give us our midline at y equals negative 0.5. And we can draw that into our graph right about there. And for B, figure out the maximum and the minimum first. So the maximum of this function is at 3. The minimum is at 0. So to find our amplitude, we do 3 minus 0 over 2. 3 minus 0 over 2 gives us an amplitude again of 1.5. Our amplitude is 1.5. Our midline is directly in between the maximum and the minimum, which gives us a midline at y equals 1.5. So y equals 1.5. Our graph is going up in intervals of 2, so that's going to be right about here on this graph. Moving on. You can model some data with periodic functions. The rotation of a Ferris wheel, the beating of a heart, the movement of sound waves are all examples of real-world events that generate periodic data. So the last example that we're going to do in this section, we're going to do a word problem. So last example. Sound is produced by periodic changes in air pressure called sound waves. The yellow graph in the digital wave display at the right shows the graph of a pure tone from a tuning fork. What are the period, and the amplitude of the sound wave? So remember, easiest way to figure out your period, you need to know the cycle. Easiest way to know the cycle is by looking at the maximum values on your graph. So between these maximum values is going to be one cycle. So one cycle of this graph is going to be between 0.004 and 0.008. That's where our cycle begins and ends, which means that our period is going to be 0.004. That's the length of this cycle. Now to find the amplitude. Again, amplitude, you need to know the maximum and the minimum values. The maximum value of this graph is at 2.5, and the minimum value of this graph is at 1.5. So to find our amplitude, we're going to do 2.5 minus 1.5 over 2. 2.5 minus 1.5 over 2 gives us 1 over 2, so our amplitude is going to be 1/2, or 0.5. And that's it for this section. Your homework is posted to Google Classroom. If you have any questions, please do not hesitate to reach out to me. Good luck.